Hi everyone, so following from that previous video, another big structural change that we've made has been on the connection system. That's probably one of the oldest parts of the network library because very little has to go on there. It only has to mediate the rest of the networking system, which is a good sign that it's been quite independent. The problem I've had with it is only been aesthetically. It doesn't look very nice. It's not very well thought through because it can't be extended very easily, and it sort of is very rigid. So there were two problems. Firstly, the fact that the authentication for connections was kind of stuck in with the actual connection management code, and also the fact that if you wanted to add more types of packets, you'd have to find out where you're going to put those functions, and you'd have one sort of big network handling function, whereas in reality you want to be able to add these features as you go. So what we've done is we've renamed connection interface to connection, and this now only mediates connection data, so it'll send packets, receive packets, and do it reliably. That's all it does, and it doesn't even actually send any data because that comes from the socket, which is given, that data is given to it or received from it. So this connection doesn't ever touch a socket, and nor does it touch any authentication data. What's used by this connection is what's interesting. So the connection, when it receives data, actually just sends it onto this thing called a dispatcher. And likewise, when it tries to send any data, it'll ask the dispatcher for any data after it does all of the things like reliable packet headers and so on. And the dispatcher basically has a number of streams, and these streams are individual subscribers to the sending and receiving of packets. So when we send data from this connection, we'll ask all of the streams in the dispatcher if they have any data to send, and we'll aggregate it. And likewise we'll do the reverse when we're going to handle data. Every single stream will be asked if they want to handle this packet collection. So our first stream in the streams, and this is the one, because it's first, it is actually inserted first into the send packets because it's ordered, is an injector stream, and all that this does is it has a queue. You can actually look at it if you like. The injector stream has a queue, and when it's asked to send packets, which is by pull packets, if there's anything in the queue, we'll create a packet collection and return it. But you'll notice it doesn't do anything with the packets it receives, which is a nice efficiency improvement. The other kind of stream we have is a handshake stream, and we'll give it some extra data below, but this handshake stream deals with the actual authentication of a connection. So if we scroll down, you'll see that we have some interesting looking functions, and these have decorators called response protocol decorators. And this is basically a very special decorator that uses the annotation system. You'll see that response protocol is just an annotation with setter with a name response2. And the purpose of this is to denote that the current function it's decorating is designed to handle any packet with a protocol as defined in the argument. So this particular function is designed to handle disconnection packets, and the one below it is designed to handle requests for connections. And we also have this thing called a send state decorator, the same mechanics behind it using annotations, and this is designed to enable enable a state machine, so that you can set the current state as, for example, the connection state, and it'll send packets according to that state, and then when you receive a reply you'll set your state to another state. So it's basically a very basic state machine, which is quite fun. So this is one of the big cleanups, and these two changes, the dispatching system and the tagging protocol system, means that it's very easy to add new features. But we haven't finished there. We've also design it so when the handshake is successful, for example, receive handshake success on the client, we create a new stream for the dispatcher, so it's all on the same level, called a replication stream, and this now handles replication. I've also done some cleanups here. Replication, it's sort of, I think it'll be faster and slower, so we have to see how that works. You'll notice that the update loop is much more simple. If it's a new channel, we create a creation packet. If it's got attributes, we'll write attributes. I don't know if I've actually tested for that there, have I? Yeah, I have. And if it's a temporary object, we just make sure we pop it from our channels once we're done. And then in the write method call, send method calls even, we then go through all of the replicable objects in the loop, and we then write any method calls that belong to those using the write method calls function. And this creates a list of packets and writes them into a queue. So the benefits of this is now we have these queues, and these are ordered. So if you look in our main queues list, we first insert removal packets, then creation packets, then attribute packets, and then RPC calls. And at the very end, in pull packets in the server, which is here, we simply stick them all into one big flat list and send them as a packet collection. So this means we can guarantee order without doing any insertions, which is technically faster. And we've also got a much more simple structure. And to add another kind of packet handler, all we need to do is create a new stream. Now, stream doesn't actually have a base class at the moment. It's sort of a convention. You just need to make sure you define a... now, where's the best place to look at this? You need to define handle packets and pull packets. And they sort of do the reverse of one another. Except pull packets also receives 2 extra arguments. Now, the difficulty with these arguments is that we don't currently... I've actually removed bandwidth management because it's not really functional. It's sort of... It's a shadow of what it should be, so we've gotten rid of that for now, and we'll add that back in later. So that's that. And hopefully all these changes will make things a lot easier to use. Now, on the horizon for the changes will also be that the serializer should now eventually be able to serialize multiple values at the same time. Beforehand, it couldn't, and that's the current state, so we need to try and move it so that it can now serialize multiple integers, just because that will increase the performance of things like list packers. So thank you guys for watching, and I'll keep you posted.